You deployed an AI model 6 months ago that passed every clinical accuracy test you threw at it. Today, that same model is producing perfectly coherent output that happens to be clinically wrong. And there is no error log, no alert, no stack trace telling you something changed. The AI you signed off on is silently drifting, and nobody in your organization is watching. I'm Chris, 20 years in healthcare, the last decade in cloud and AI. I'm the healthcare architect. Today I'm explaining why LLM drift is the operational risk nobody's monitoring, and the 5-part architecture that catches it before it becomes a liability. Here is what people do not want to hear about production large language models. They degrade. Not with a crash or a corrupted file. They degrade by slowly shifting their behavior while still sounding completely competent. This has a name, model drift, and it works differently from every other software problem you have ever managed. Traditional applications throw exceptions when something breaks. A null pointer, a failed database connection. You get an alert, you open a ticket, you fix it. A drifting model produces polished prose that happens to contain a clinical error. There is no log entry for that. Drift happens through 3 mechanisms, and at least one of them is completely outside your control. First, the AI providers themselves push silent updates. OpenAI, Anthropic, Google, all of them constantly tune their models for safety, speed, cost reduction. A tweak designed to reduce toxic outputs in one domain can quietly degrade reasoning accuracy in another. You do not control the release schedule. You suddenly wake up to different behavior. Second, the world changes while your model sits frozen. New drug names enter circulation. Clinical practice guidelines get revised. Patient demographics shift across your catchment area. The model's internal knowledge represents a snapshot of training data that is now 6 months out of date. The gap between what the model knows and what your clinicians need keeps widening. Third, and this is the one that catches engineering teams off guard, is compound drift in agent workflows. When you chain multiple model calls together, a tiny variation in step 1 multiplies across every downstream step. Think of a rounding error that bankrupts a trading algorithm. That is what happens when drift enters an agent pipeline. By step 5, your output is meaningfully wrong and nobody triggered a warning. The reason drift goes undetected is that most organizations are monitoring the wrong things. You are checking uptime. You are checking latency. You are checking whether the connection returns a response. Those are infrastructure metrics. They tell you the system is alive. They tell you nothing about whether it is still accurate. 3 specific failure modes are happening right now in production healthcare AI. Silent failure. A clinical summarization pipeline processes a longitudinal patient record. It produces a well-written summary, medically coherent, except it dropped the patient's penicillin allergy. The allergy is simply absent from the output. No error was raised. A 2026 Stanford-Harvard study of 31 frontier LLMs across 100 real outpatient cases found severe clinical errors, including critical omissions, in up to 22% of cases. Calibration drift. Your risk scoring model was validated 6 months ago. It correctly stratified high-risk and low-risk patients against actual outcomes. Today, the calibration has shifted. The model is systematically underflagging patients who need intervention. Triage priorities are being reordered without anyone reviewing the signal. Another study documented this exact pattern, detecting significant data drift in a clinical prediction model within 2 years of deployment. The model still returns a probability score. It is just no longer aligned with reality. System breakage. Applications that depend on structured outputs break when the underlying model changes its formatting behavior. A safety update adds a conversational preamble to every response. Your clinical decision support pipeline expected a structured data format. It now receives a friendly greeting followed by data in a structured format. The pipeline crashes. The model did not get dumber. It just changed how it talks. Your integration was brittle. None of this requires new technology. It requires infrastructure discipline. 5 components, each one already standard practice in industries that take model risk seriously. Number 1. Stop pointing at moving targets. Do not use tracking endpoints like latest model or GPT-4o. Pin to specific dated model snapshots. You control when the model changes. You regression test before migration. The LLM ops community now treats version pinning as a foundational deployment practice, not an optional configuration. Number 2. Build an evaluation benchmark. This is a reference dataset that reflects your exact production use case, your edge cases, your formatting rules, your complex reasoning chains. Run your system against it automatically. When the scores shift, you know before your patients encounter the degraded output. Monitoring platforms both treat benchmark regression testing as the primary gate for production LLM deployments. Number 3. Enforce structured output with format rules, not prompts. Prompts are polite suggestions. Format rules are enforceable contracts. Use structured format validation and output generation libraries. Anything that programmatically guarantees the output shape your downstream systems depend on. Number 4. Supply the model with real-time verified data instead of relying on its internal knowledge. This connects the model to a live knowledge base. The model reads from an updated knowledge base rather than recalling facts from training data that predates current clinical guidelines. You reduce your exposure to drift because the facts live outside the model. A 2025 MDPI review confirmed that connecting to a live knowledge base significantly improves factual consistency in healthcare LLMs by grounding outputs in verified clinical sources. Number 5. Continuous post-deployment monitoring. Track output distributions. Track clinical accuracy metrics. Track them over time. When the numbers move, investigate. This is how banking monitors fraud detection models. This is how aviation monitors engine performance across fleets, a market valued at $4.7 billion in 2025 and projected to reach $7.8 billion by 2034. Healthcare AI needs the same discipline. Other industries solved this problem years ago. Banking regulators have mandated model risk management since 2011, updated in 2026 to explicitly cover AI, requiring independent validation, continuous monitoring, and board-level oversight. Healthcare has deployed AI into clinical workflows without equivalent guardrails. We are monitoring language models like static websites. This is not a model accuracy problem. It is an architecture and operations problem. The AI you deployed 6 months ago is not the same AI running today. The question is whether you built the infrastructure to notice. The organizations that deploy version pinning, evaluation benchmarks, structured output enforcement, and continuous monitoring will be the ones whose AI does not silently fail on a patient. The ones that do not are running an uncontrolled experiment in their clinical operations. They just have not realized it yet. I'm the healthcare architect. See you in the next one.